So for this one, it's asking what is the doubling time for the fish population. So the way we can kind of figure this out is we can figure out, at time zero, what is the population by plugging in zero for t, and then figure out how long it's going to take for that to double. So if I plug in zero for t, I get e to the zeroth power, which is 1 times 9, which is 9. So I end up getting 1,000 over 1 plus 9. That's 1,000 over 10, which is 100. So at time zero, we have a population of 100. So then I want to know how long is it going to take to get to 200. So now we're going to plug in 200 for p, and we're going to solve for t. So we're going to start by multiplying both sides times that denominator. So 200 times that denominator is 200, plus 200 times 9 is 1800, e to the negative 0.6 t, and this equals 1,000 because when I multiply the right side by the denominator, it just cancels that denominator out, so we have 1,000. Now I'm going to subtract by 200, and I get 1,800 e to the negative 0.6 t equals 1,000 minus 200, which is 800. Then we're going to divide by 1,800, and I get e to the negative 0.6 t equals 800 over 1,800, which is 8 over 18, which is 4 over 9. Now, since I have an e and an exponential variable, I need to take a log. I'm going to take natural log because we got e there. So I'm going to take natural log of both sides. That's going to cancel that out and allow me to bring this down to be negative 0.6 t equals ln of 4 over 9. Last but not least, I'm going to divide both sides by negative 0.6, and we're going to get our approximation for t. We're going to use Desmos to get that approximation. And rounding that up is going to be 1.4. That's to the nearest tenth. So it takes approximately 1.4 years. Finally, just one other last thing to know when it says what is the doubling time for the fish population. Since this is a logistic function, the doubling rate doesn't stay consistent, right? So for example, in an exponential function, the doubling rate is consistent. Let's say it's 5 days, it's always going to be 5 days. For a logistic function, it kind of speeds up and then the rate of growth slows down. So this is just a doubling time for the fish from that initial population, just to clarify.